Sometimes our mathematical models are not given as explicit formulas where we just know the input and we can get the output, but instead we have what's called a recursive model. And this is when the value at one input is determined by outputs of previous values. Meaning for example, if I knew the population last year, then I can find the population this year. Something like that. Because these are different, like we don't usually have formulas for these, meaning plug in the input and get the output, we won't use function notation usually. We'll instead use subscripts, kind of like this example right here. Okay, so f sub n is equal to f sub n minus 1 plus 3. So we're using subscripts here to indicate what our value is after n iterations. And furthermore, sometimes we'll talk about these as sequences rather than functions, because we're just plugging in like discrete numbers, 1, 2, 3, 4, instead of like all possible values in between. So here's an example just to kind of get a feel for what we're doing here. We've got f sub n equals f sub n minus 1 plus 3. And then attached to that, we have f sub 1 equals 2. And this is a very common thing when we are using recursive formulas or relationships. We have to know at least one value. Otherwise, the relationship itself doesn't really tell us anything. So we're usually given an initial value. So when n is 1, we know that our f is 2. And then from there, we can find further things. So we're going to find f sub 5 here. Now, I want to point out that to find f sub 5, okay, n is equal to 5. And if n is equal to 5, then n minus 1 is equal to 4. So to find f5, we're going to take f4 and add 3. Now, the problem is we don't know f4, do we? We only know f1. So instead of going through this process, we're actually going to start at f1 and figure out what we can find from there. So I'm going to make a little, I'm just going to list these out. So f1 is 2. Okay. So the next term, f sub 2, well, that's when n is 2. So that uses f sub 2 minus 1, which is 1. That uses the previous term and then plus 3. Well, we know f1. f1 is 2. And so this is 2 plus 3, which is 5. So now we know f2 is 5. Then we can find f3. To find f3, we're going to use f2 plus 3. Well, f2 is what I just found. That was 5. 5 plus 3. That's 8. To find f4, well, that's when n is 4. I have f3 plus 3. And f3 is what I just found. That's 8 plus 3, which is 11. And finally, we can find f5. And we already know, well, f5, that was f4 plus 3. And f4 is what we just found, 11. So 11 plus 3, which is 14. So using that recursive formula, we were able to get f5.